Hello and welcome to another Be.Tech.Construction lecture. This series is going to be called Building Information Modelling, and we're starting with why BIM. So why BIM? Why is building information modelling needed? It has been known for a long time now that construction in the construction industry is inefficient and wasteful. The industry has been called on to change. We need to understand the world is changing in many ways. We are in the digital age, and construction needs to embrace this. We have an ever-growing population. The world is changing in negative ways too, as our impact on the environment has become obvious. We need to consider our industry and how it relates to all of the things above, and how we can aim to positively improve in all areas. BIM is the industry's response to the above issues, and we will be looking in depth at what BIM is in this series of videos. Information. If you consider a construction project from start to finish, you must try and comprehend the amount of information involved. Each person will try to convey their ideas to another person or many other people via forms of different information, whether that be face-to-face or conference call meetings, written reports, method statements, risk assessments, surveys, spreadsheets, construction drawings, 3D digital models, and many more ways we try to communicate to each other. Making sure that the transfer of information is 100% effective, i.e. fully understood by the recipient, is impossible. There is simply too much information and too many people involved that mistakes are inevitable and unfortunately frequent. BIM looks to reduce these issues by major improvement in how information is managed. In fact, a lot of people think BIM should stand for Better Information Management. Coordination. If you consider how many things there are in a building, such as steel beams and columns, pipework, electrical cable trays, ductwork and ventilation, fire alarm systems, underfloor heating systems, security systems, access control, walls, doors, structural framing, data cabling, need I go on? Now imagine for each element of the building there is one company per system designing that system. You can have scores of companies each trying to design their own part of the building. How do they make sure that they do not locate any of their items in a space that another company has located one of their items? We call this a clash. For the longest time, coordination has been a major issue, and the clashes were simply expected and resolved on site when the building has already begun. It's extremely costly to rectify issues on site. BIM looks to massively improve coordination between everyone working on the design and highlight clashes long before construction has started, saving a lot of time and money. Earlier attempts. For a long time the industry had been known to be inefficient and wasteful, and reports such as the Egan and Latham reports pointed this out and offered advice for practice to improve things, but the industry is known to be resistant and slow to change. BIM Standards, Methods and Procedures really started with a document from 2007, which was a British standard called BS 1192-2007. It's now part of the ISO 19650. These standards were still not adopted until the government eventually introduced a mandate, which we will discuss later in these lectures. Poor information. Imagine a project that involves just one person, you, for example, and you are looking to design and build a shed. You will be responsible for producing the architectural drawings, the structural drawings, and the building service drawings. That's the mechanical, electrical, and plumbing parts. You will be responsible for deciding on materials and all design aspects. You will be responsible for collecting and delivering the materials and for constructing the shed itself. You will be the person who then uses the shed when it is built. The chances of mistakes will be low because you can coordinate in your own head. You know where everything is going. You will know whenever a drawing is updated, as it will be you who is updating them. When it comes to constructing things, your drawings won't have any ambiguity because you drew them and will understand them. As soon as you add one more person to a project, you increase the chance of mistakes because now we have to convey information back and forth. One person has to convey the information correctly in the first place, and the recipient has to have understood what was said. If one or both of these things doesn't happen, you have a problem. Imagine you bring on board one person to deal with the structural frame drawings of your shed. How can we be sure that the drawings will match the architectural and service drawings? The two people will need to coordinate and look for clashes. What if one person makes a minor change to their drawing but forgets to inform the other of such small changes? Someone will be working off of information that is not the most recent revision and may decide to make some changes on their own work that works with the old information but will clash with the most recent revision. Now try and imagine that scenario with a big building. There could be 30 different companies and 100 different people involved with the project at some point. Everyone producing their own information. All of this information is supposed to match up exactly. I don't just mean drawings either. Written reports, survey data, spreadsheets and drawings all have information on that needs to match up. If we did have 100% accuracy on a project without a single mistake or misunderstanding of any information, we could call this the truth. BIM is always trying to find the truth in any part of a project. Global BIM. All these issues mentioned in this lecture around construction are not unique to the UK. We find the same issues in construction in every country in the world. Many countries around the world have certain types of mandates in place so that BIM must be used in certain circumstances, and that includes the UK, which we will discuss in later lectures. The EU has the EU BIM Task Group. Construction 4.0. We have moved into the fourth major revolution and we are in the digital age. Construction must move with this revolution and harness the power of new technologies. Off-site construction, drones, 3D printers, artificial intelligence, virtual and augmented reality, and the digital twin are all the kinds of things that we are now beginning to use in this industry, and we will cover some of these in later lectures.